Hey everybody, thanks for joining today's nTop Live about how to generate reports to help keep track of important details such as lattice, mesh, and mass properties. And this is a continuation of my last nTop Live, which was about managing and tracing design variations using a unique file naming scheme. Today, I'd like to show a workflow in nTop platform that uses a similar approach, where we can combine text together to create a text file report alongside the STL that we exported. So as a refresher, we can see that we have on screen is a tibial tray orthopedic implant with a lattice structure on it. And this implant is one of the components typically used in a total knee replacement surgery. And the lattice structure that we have on this surface is considered osteointegrative. And that basically means that it's a bone-friendly interface that can better promote bone growth after the surgery takes place. We generated this osteointegrative lattice in nTop platform by designating a beam thickness, which uniformly applies to all the beams in this lattice, as well as a pore size, which is the approximate average size of the pores or empty regions that exist throughout the lattice. The pores here are usually quite desirable for this kind of application because these empty regions allow the bone-forming cells to kind of seep in there and solidify, allowing them to really grab on and take hold of the implant. What we also have here is it's a randomization seed, and this input isn't super critical when it comes to the lattice geometry itself, but it is a necessary seed value that the randomization originates from. And it is important to keep track of this if we ever want to create this exact lattice structure again. Now, because the mesh is already generated and exported, we can actually pull up our folder and see that this STL file already exists alongside our nTop file. And as we designated in our last video, the name of the STL file is in the name of the part, along with the input parameters of the beam thickness and pore size. So let's take a peek again at how that works. Inside of this text list, right over here, we concatenate a series of strings, text strings, to essentially assemble our output file name. The directory comes first, and that indicates what folder we want to save it in. Then we have this part which just says tibial tray, the part name, a call out to the beam thickness, and then a variable that is directly connected to the input value that we designated for the beam thickness. So it says 0.35 millimeters up here, and our file name shows that same value. If we were to change that to something else, we would essentially generate a brand new lattice, export a brand new STL file, and it would have that updated file name. If we were to skim through the rest of this list really quick, we can see that the pore size text is constructed in the same manner with the file extension of an STL, rounding out our entire file name. So keeping all this in mind, we can now follow similar steps, creating a text file instead of an STL file. And that could be done through this block here called the export text block. Instead of recreating this entire concatenate text workflow that we have right up here, we can actually right-click it and use the duplicate feature. This feature kind of makes an exact copy of all the contents that we've selected, but they're actually disconnected so that we can actually make changes to this new copy without impacting the contents of the original. So let's go ahead and do that. Close up the original and rename the new one appropriately. So let's call this report file name text, just so we can distinguish between the two. And I guess for even better housekeeping, we can actually rename the original one to STL file name text for even more clarity. Awesome. So with this duplicate, I'm going to change only the file extension from .stl to .txt. And that way, when both the STL and the report are both exported, they'll always have the exact same name because the constructor to assemble their file name is basically the same thing. So let's bring it down here real quick and get that closer to the correlating export text block. And we're going to go into the properties and close the loop by connecting this path. Just like that. So now we have a place to save the report. What are we going to put inside of it? So first off, let's make sure this works, and let's just put some arbitrary text in there. So we can type in your classic hello world. And once we accept that, we can actually open up the file itself, we can see that a text report with the same name has been generated. And if we open that up, we can see our hello world. So now that we know that works, we can put in something real, right? I'm gonna erase this hello world, swap the overload to accept text lists. And now I'm gonna drop in this text list that I already have. And if I open this up, you can see that this text list already has the components to report things like the beam thickness, the pore size, and the randomization seed. So if we open that report now, we can see that the contents of the text file reports the inputs that we plugged in. Now, this is a really good start to reporting all the pertinent information that we do care about. So the question now becomes, what else can we expose, right? So let's go back to the design workflow and start digging into those properties. This one right over here. If we open up this lattice graph, we can see that the edge count shows that this lattice has around 39,000 beams, and the vertex count shows that it almost has 30,000 nodes as well. And if we open these up and dig into those properties, we can see that each has a sub-property called text that we can grab and use for our report. And we can do the same thing with the mesh that we've created also, right? So if I open this up, we can see that the mesh has over 1 million faces and over 500,000 vertices. And this is also information that we can grab and report. But if we scroll back down to the text list, it can be, certainly a bit cumbersome and kind of annoying to create all these individual text lists and just combine them together for each individual value that we want to expose. So what I have down here at the bottom of my notebook is a few custom compound blocks that I put together that makes this whole process really easy. So this may seem a bit daunting after I first open it up. There's a lot going on here, but it's actually quite simple. So I made a customized reporting block that can report a whole bunch of different parameters by simply dragging in the object itself, right? You're not having to dig through each block's individual properties to grab that specific component that you need to report. So if I open up something like this, report lattice beam count, it only takes a single input, and it's the lattice graph that we generated earlier. This one right over here. And the custom block that I created knows where inside the properties to go to grab the right information, right? Same deal with the report mesh triangle count block that I have right over here. All it needs is the mesh itself, and it can instantly grab the number of triangles that are in that mesh because that's what this custom block was specifically designed to do. So with all these really handy custom blocks that we see over here, it makes my report generation really easy after I've put them together for the first time. So all this robust report needs from here on out is just this path. And we're gonna steal that from right up here from before, drag that over, and we're done. If we open up this file again, we can see that this robust report shows more than just lattice beams and mesh triangles, but it's built to calculate mass properties. It can calculate input parameters, bring those down from above, relative density of the lattice structure, and so much more information, and really whatever you want to put in here. So that's kind of the entire report that we've put together for this specific workflow. So as a final step, we can actually put this whole workflow to the test. We can do the lattice generation, we can do the mesh generation, we can have this customized file name when we export, and we're going to have a tailored report generation as a part of this workflow process. So let's update the beam thickness. Let's bump it up to something a little less dense, and let's say it's like 500 microns for a beam thickness, and let's do 1.5 millimeters for a pore size. And for funsies, we can also maybe change the randomization to something like 200. So let's give it a quick second just to run through this in the entire workflow. And as a note, what's going to take the longest here is going to be the mesh generation itself, because a bit more of a dense lattice is involved. So it's going to take a little bit of time to generate and wrap all the geometry in the proper amount of triangles. I'm going to close up these instances of the old reports. We're at 33% right now. It's almost done. And boom, just like that. So the mesh is done, right? We can see on the screen, the STL itself was exported and a corresponding report was created. And we can see that here, right? The STL with a 500 micron beam thickness and a 1.5 millimeter pore size and its corresponding report. So if we dig into that, we can see that it's tracked our new inputs right over here, reported all the new values that are specific to this new lattice. And it'll actually continue to run and maintain itself as you put in new values and new inputs. So this idea of creating reports that are connected to all the inputs and properties of our workflows, it really ensures that every step of your design exploration can be managed and traced, right? If you're doing a design of experiments and want to easily manage each new set of results with each set of inputs, this would be the perfect way to kind of make that pretty seamless. If you're working with a huge product family with maybe tens or hundreds of part configurations, this would be a really easy way to ensure that your process is bulletproof, right? With each report, the design engineer can essentially ensure that like each input parameter for your design workflow is being tracked and it is traceable. Any errors or discrepancies will immediately show up in the file name or inside the report itself. So if something does go wrong further down the road, each report can be credibly used as a reference, just to ensure that the outputs that define your specific part configuration, they're exposable and just easy to comb through for traceability purposes. So if anybody has any questions, please don't hesitate to throw them at me now. I do hope this has been interesting and perhaps maybe it'll inspire you to start building these auxiliary reporting workflows that can essentially keep your design process that much more traceable. Obviously, what I've shown you today is not really intended to be a be-all, end-all solution when it comes to keeping track of your geometric properties or really serve as a replacement for your existing traceability processes. But this is just a showcase of what nTop can offer as a design platform to create these nuanced solutions that work for your specific application and serve your specific needs, all while supporting really just a more traceable process across the board. So with that, I'm gonna hop into the Q&A and see if any questions come through. One of the questions that came through is, how do you convert scalars into text? And that's a really great question. When you have a scalar value, something like this beam thickness or this pore size, we can see it represented as a scalar data type due to the little icon in the top left corner, right? If I hit the info tab and I come to the information, we can see that it is an output scalar type, right? That's just a good way to track and understand what each block's type is going to be. So in this case, it's a scalar, and we want to grab the text information. We can actually come down to the properties of the object itself, and there's always going to be a text version of that, right? So we can just click this text chip and drag it to wherever we need to drag it. It's a quick example of how that'll work for something like the mesh. We can go into the properties tab, find something like the face count, which is 805,000 for this specific lattice. We open that up. There it is, that text component or that text subproperty of 805,000. We can bring this and drag this to wherever we need to. There was a follow-up to that same question asking if it is the same value. That's a good point to bring up. So in the case of the mesh, right? If I bring up this properties tab again, you'll see that if the face count is 805,000, the text will reflect that exact same number, right? Because it's just counting a specific value or a specific number that's kind of like a property that's intrinsic to the mesh itself. But if you notice with something like the beam thickness, where it's 500 microns or 0.5 millimeters, If we'd open up that properties tab and look at the text, we can see it's actually smaller by an order of 1,000. And what's actually happening here is that this text is by default calculating the units in meters, which is our default unit scale. So even though it's in millimeters, it does that conversion live. So what we actually end up doing for the input specifically is that we do a minor correction with the unit conversion. So you can see here that I've got a kind of like this group or this folder of blocks called the math folder. And you can see that here, I just multiplied that beam thickness by 1,000. And that brings me up to the right text value of 0.5. Just a minor nuance with the way we handle units and the way we handle text properties. I'll give it a few extra minutes, and if anybody has any further questions, feel free to throw them at me. While we wait for those, I can kind of talk about the way we constructed the individual lines on the report. You can see that not only do we have the values, such as this lattice node count, this value is looking at a property, and that's always going to be dynamic based on the lattice structure that you generate. But we've also got this string of text right above it, or right next to it. It says lattice node count colon, and then 2 spaces. And that's actually something that is kind of hard coded into this specific text list, right? The first being the key, and then the second one being the actual value. The concatenation block just combines these together into a single line, right? So that's what I meant when I said that approaching this can be a bit cumbersome if you have a lot of individual properties that you want to report. So that's why I kind of built all these custom workflows, these custom little blocks that essentially kind of do this for you, so I don't have to recreate and retype that every single time. Makes things really convenient. Okay, I don't really see any more questions coming in. So I just want to thank everybody for stopping by to the nTop Live. As a note, this will be recorded and put up on our YouTube channel. So if you do need a quick refresher, or you want to kind of just go through it again, just to maybe recreate some of the workflows themselves, it should be up on our YouTube channel in about a day or two, maybe a little bit more, depending on what that looks like. So thank you again, and have a nice day.